What's up guys, welcome back to my channel. Today we're going to be solving a programming interview question called Find the Duplicate Number. This is a medium level question and the problem description goes like this. Given an array nums containing n+1 integers where each integer is between 1 and n inclusive, prove that at least one duplicate number must exist. Assume that there is only one duplicate number, find the duplicate one. So here they give us two examples. The first one with a list of integers with the numbers 1, 3, 4, 2, 2, and the output is 2 because there are more than 1, 2 in that list. And in the second example, there is an input of a list of integers with 3, 1, 3, 4, 2, and the output is 3 because there is more than 1, 3 in that list. So note that you must not modify the array. Assume that the array is read-only, so the array here cannot be altered in any way. And you must use only constant O of 1 extra space, so we cannot store another list with all of the integers again or do more than that. And your runtime complexity should be less than O of n squared, so you cannot do a double for loop to find the solution. And there is only one duplicate number in the array, but it could be repeated more than once. So the duplicates here are 3 and 2, but the 3 and the 2 here could appear more than 2 times. The way we're going to solve this problem using constant space is with an algorithm called Floyd's Tortoise and Hare cycle detection. And basically in this algorithm, there are two pointers. The first pointer is the tortoise and the second pointer is the hare. And the tortoise is going to take one step while the hare takes 2 steps. When the tortoise and the hare reach their intersection point and the values of where the tortoise is at is the same as the value where the hare is at, we are going to stop. And then we're going to loop through the list again and find the entrance to the cycle. So for example, here we have 2 pointers. The first pointer is the tortoise and the second pointer is the hare. And they're both at numbers at index of 0. And the numbers at the index of 0 is 1. So the tortoise will move forward to numbers at the index of 1. And the numbers of the index of 1 is 3, so that the tortoise is at 3 right now. Then the hare will go to the numbers at the index of 1 also. And then after that, it will move one step forward to the index of 3, which numbers at the index of 3 is 2. So the hare is at 2 right now. Now the tortoise is going to catch up with one step forward, and it's going to numbers at the index of 3, sorry. And so the number at the index of 3 is 2. So the tortoise is now at 2, and now the hare is going to go 2 steps forward, and it goes to the numbers at the index of 2, which is 4. So it goes up to 4, and then it goes to numbers at the index of 4, which is 2. So now we see that the tortoise and the hare have the same values, which is 2, so that is the duplicate number, and that is where the tortoise and the hare intersect. Now that we have found the intersection point between the tortoise and the hare, we need to find the entry point to our cycle, which will give us the pointer to our duplicate number. To find the entrance point of the cycle, we need to have 2 pointers. The first pointer will point to the numbers at index of 0, pointer 1, and the second pointer, pointer 2, will point to numbers at the index of the tortoise. And then each pointer will go forward once. So the pointer 1 is at index 0, and it will go to numbers at the index of 1, which is 3. And then the pointer 2 will go to the numbers at the index of 2, which is 4. And it will keep doing that until it reaches an intersection point again. And this time it will stop when it reaches to the same index. So once we get to the same index, which is index 3, we find that our duplicate number is there, and the duplicate number is 2. Alright, now that we know which algorithm we're going to use to find the duplicate number, we're going to implement Floyd's tortoise and hare cycle detection into code. So the first thing I'm going to do is set the tortoise pointer to point to nums at 0, which is the first item, and the hare to nums at 0 also. And then we're going to loop through while true. and see if the tortoise can go one step forward and the hare can go 2 steps forward until there is an intersection. So tortoise is equal to nums at tortoise, because remember they keep going 1 step forward based on their values, and so the hare will move 2 steps forward, so it would be nums at nums of hare. So here the hare moved once in the nums at hare, and it will move again at nums of nums at hare. So after that, we'll see if the tortoise and the hare intersect. So if tortoise is equal to the hare, that means they have the same values. We're going to break it. So once we break it, we know the intersection point between the tortoise and the hare and the value of that. Now we'll find the entry point to the cycle. To do that, we're going to set the pointer 1 to numbers at the index of 0, and the pointer 2 will be the tortoise. And we're going to have a while loop and say that if the pointer 1 is not equal to pointer 2, we're going to move the pointer 1 forward. So pointer 1 is equal to the numbers at pointer 1, and pointer 2 is equal to the numbers at pointer 2. And when those 2 pointers meet at the same index, we're going to return pointer 1 in order to get our duplicate. So now let's try and run the code. And we see that it returned the duplicate number of 3 in that list successfully. That is the way to find the duplicate number. I hope you all enjoyed this approach to solving the find of duplicate problem. If you like this video, please give me a thumbs up, or if you have any questions, please comment down below. Please don't forget to subscribe, and thank you so much for watching. See you in the next tutorial. Bye.